In this video, I will be explaining geometric sequences and how to write and solve them. So a geometric sequence is a sequence whose consecutive terms have a common ratio. Now, arithmetic sequences that we've discussed in the past is going to be a common difference, like it adds by the same number every time. In a geometric sequence, it is going to be multiplied by the same number each time. So if you notice between this sequence, if you multiply by 2 every time, you will reach the next term of the sequence. So in this case, the next number in the sequence should be 32. Here's where you have to be careful. You cannot say divide, it has to be multiplied. So you could say, well, 9 divided by 3 and divide by 3 and you're divided by 3. But because it's a ratio, you got to think it in terms of multiplication. So the answer is going to be 1/3. 9 times 1/3 is 3. 3 times 1/3 is 1. 1 times 1/3 is 1/3. 1/3 times 1/3 is 1/9. So it has to be in terms of multiplication. The formula for the geometric sequence is A of n equals the first term times r, which r represents ratio, to the n minus 1. So in this case, the formula would be A of n equals the first term, 12, times the ratio, which is 3, because 12 times 3 is 36, 36 times 3 is 108, 108 times 3, raised to the n minus 1. That is actually the formula for a geometric sequence. So to find the n term of the sequence, let's go ahead and plug in what we know. Well, the formula is the first term times r, which I use parentheses to make it easier to distinguish, to the n minus 1. Well, we know the first term, it's 10. We need to find the ratio. So to get from 10 to 5, you had to divide by 2. But since, again, we have to think of it as a multiplication, that means you multiplied by a half. And did you multiply by a half again? Is 5 times a half 5 halves? Yes. That means the ratio was 1/2. And there's your answer. No need to simplify. Now, in this instance, you're finding a specific term. In order to find a specific term, you need to go ahead and actually write the formula. Again, the formula is going to be the first term times r to the n minus 1. Well, that is our first term. And then to figure out what you multiply by each time will get you r. 1/2 times what will get you 2? 2 times what gets you 8? 8 times what gets you 32? The number is 4. You're multiplying by 4 each time. So therefore, the formula is going to be the first term, a half, times the ratio, 4, to the n minus 1. Now, it wants to know the 12th term, so you are going to plug in 12 into that. So therefore, it is going to be 1/2 times 4 raised to the 11th power. You don't do 4 to the 12th minus 1. You got to understand, please excuse my dear Aunt Sally, you need to do the exponent first. So you need to subtract 12 minus 1 first before you raise it. So 4 to the 11th power, and then you're taking half of that. And your answer is 2097152. So 2,097,152. In the arithmetic sequence, we have one like this. It's going to be the same concept in this term of the fact that you have the fourth term is 125. So I know that the fourth term is 125, and I know that the 10th term is 125 over 64. Now, for the arithmetic, we actually subtracted. We actually made it look kind of similar to a slope, to where you're figuring like what adds every time to get to that. And so we subtracted these terms, and on the denominator we subtracted these terms. But that is for a common difference. The fact that this is a common ratio makes it a little more difficult. And so here's how you do it for a ratio. You actually will divide the value of the terms, and you're going to set that equal to subtracting the terms as an exponent. So the 4th term and the 10th term means that there were 6 terms in between there. Going from the 4th to the 10th, you had to go through 6 terms. Which is why it's an exponent, is because you're multiplying by the same number 6 times. So if you're multiplying by 3 and you're doing that 6 times, that is where you get 3 to the 6. So that is why it is raised. And then you are now having to divide by here. And when you do 125 divided by 125 divided by 64, you actually get 64. Off to the side, think of it as this way. 125 divided by 125 over 64. And if you remember from the past, KFC, you will keep it, flip it, change it. The 125 divided by 125 basically eliminate each other, leaving you 64. So you have r to the 6 gives you 64. So what you have to do is to figure out what term will give that to you is basically you've got to raise, or you got to find the 6th root of both sides, which I believe gives you a 2. The 6th root. Yes, it's 2. How do you put a 6th root in the calculator? You would do 64 raised to the 1/6 power. That's actually how you would put that in the calculator. So we now know that r is 2. Wow, all that just got us to r. Now we are going to have to write what part of the equation we know so far. We know not a of 1, but we do know r to the n minus 1. Now, we are going to choose one of these terms to actually plug in the answer to find the a of 1. Well, I know if I plug 4 in for n, then I should get an answer of 125. So 125 is going to be what you get if you plug in 4 into n. Well, 4 minus 1 is 3. 2 to the 3rd power is 8, which means our first term was 125 divided by 8. So our final answer is 125 divided by 8 times r, which is 2, raised to the n minus 1. Fortunately, we're not done, because it now says find the 14th term. So what do? You plug in 14 in for n, and you'll finally have your answer. So 125 divided by 8 times 2 raised to the 13th power, because remember, 14 minus 1 is 13. So I'm going to do 125 divided by 8, and then parentheses around that, and 2 raised to the 13th power gives me 128,000. So there's a few things we had to do here. We first had to find r. Once we found r, we had to find our formula. Once we found our formula, we had to find the 14th term.